basically grow on it. It's actually somebody sit in the office and type in the computer and say, when somebody double click on this, I'll get a message, and on this message, I'm going to do 1, 2, 3, 4, 5. Okay? Yeah, you need some kind of interface here for your program, right? Just like we have an interface like this, right? But you need an interface so that you can, minimum interface, right? So this is basically all the components you need to get started with a prototype. Some functionality, okay? We're not requiring to learn very fancy things. This is basic or minimum Java, and with a little bit of communication to chain, to group a number of applications together. Okay, so your requirement stage, as we discussed, is to basically you sit down and analyze this and see what functionality is needed here, right? First of all, your program need to provide login functionality. First of all, so from very beginning, you should be able to sign up new users, right? If you have no capability to sign up no new users, nobody can log in. There must be first user sign up somehow. Certainly, for Facebook, they can always, those apps, they can always go behind the scene and not using the regular sign up interface. They can have their own interface to sign up or just populate the database, but that's a different thing. So here, basically the first functionality you would need sounds like you need that new user sign up, right? What is the new user sign up? I come in here, there's a new user button or new user string. Whenever I click on that, it goes to the next page, right? Okay. Once that, so I put in my name, my password. You may actually want me to actually type my password twice, right? Then once I click sign up, right? You have to encapsulate that information into your packet you send over to your server. I don't care about security at this point. It's up to you, to whether you want to send it in plain text or you want to send this over a protected link. But protected link is something you can learn. In Java, it's not hard to learn this, but it's not a requirement. I'm not requiring to enforce security. We're talking about strict functionality here. So that username and password need to be sent to your server. Your server has to be logging all this information into a database. You may say, oh, I never learned database before. We already practiced database in our first 2 quizzes. What did we do in the first 2 quizzes?
Linked list.
Linked list. In the worst case, you can always simply put your user and password in a linked list. That's it. Okay? No, nothing fancy there. You may say, oh, I never learned database. I say, oh, I already teach you how to do database. Right? Your linked list is one way to save this information on the server permanently. However, now come down to your linked list. If you do save your information in a linked list, when the server shut down, you better have a way to write this linked list out to a disk file so that next time you relaunch a server, you don't have to re-enter the user information again and again and again, right? That's not even required, okay? Because we can assume if you don't want to do that, then essentially every time you have to retype the same information. That's why some smart people years ago decided that we are not going to retype that information millions of times. We're actually going to store that in a file on a disk. And every time we'll reload that information out so you don't have to retype your username and password every time. Okay? So you have to be able to do that. Then once you have username, so new user sign up sounds like a use case, right? The second thing is user login, right? User should be able to log in. Next, user should be able to send message to everybody, broadcast. Next, user should be able to send message to selected people. Right? User should be able to go check on existing chat. Okay? What else? Have we covered them all? Then you have to worry about all the error message situation. Okay. That's pretty much how you should be going with your analysis, or with your requirement analysis. These basically you articulate. This is a set of functionality I'm going to implement. How do you represent that information? We already started talking about that last time. This use cases. Okay. Here I'm actually talking about the functionality of the program. Okay. However, when we come to use cases, okay, I think this is only maybe this one. Okay. When we come to use cases, okay, what is the system we're talking about here? In our case, this is the banking software system. Just for example, they have customer and teller. This is actually a more complex way of representing to actually a pretty complex use case, because you have customer actually going to withdraw money through a teller, and customer talking to the teller, and teller actually withdraw the money for the customer, and so forth. If it's an automatic teller machine, it's going to be a little bit simplified. But in our case, if we are going to analyze the system, how should we go? What is our system? Chat app. Okay? All right. Guess what? At the beginning of analysis, this is actually your internal system architecture. From a client point of view, the client will never need to know you are using a client-server architecture. Your real customer, they will never need to know you are using a client-server architecture. That's your problem, not their problem. They don't need to know. Just like when I go talk to my mom, and who's 85 years old, and say, do you know a client-server architecture? She will say, go away, right? She just care about being able to talk to me over something. I mean, no, why would she care about? So that's our problem, not their problem. That's exactly why we are learning the inside. We are actually going inside our system, and the common user, they will never even think about the inside of the program. What they just see is only outside. So you actually have client. I mean, so in this case, well, just going to say, okay, a user. Okay, this guy just here, and okay, I'm just seeing a chat app, right? Whatever in the middle, I don't care. It's your problem, not my problem. At the very beginning, you as developer, you as the product manager, should hold this view as well. I know nothing about the internal of the system. I'm only observing the system from outside. Can I look into this and see how many things inside? I can. But I do know the functionality of this thing from outside. So, number one, I'm going to have new user registration. I need that. Right? If you don't have that use case, this thing is useless. All right? Anybody have different thinking? This is the first use case we need. But what does this tell us? This is our use case diagram. This is my first try for my use case diagram. We are not looking into the system. We are basically observing the system from pure outside. We know who are the users, who are the client. That's why it's called use case diagram. User of ChatApp. Do I care who that person is? No. It can be any general person. Okay? However, we do know the first thing this user would demand from the program is I should be able to register my information with this app. This is functionality number one. This is how we go about. So your goal in terms of requirement is to enumerate the functionality the user will view from outside. However, so why this cannot be automated by machine, can only decided by us. What exactly is the granularity of your use case? Right? What is the minimum, smallest action you would put on this diagram? Do you put new user registration? Or do you even go into, type into username dialog box? That is actually your decision to make. Okay? That is actually your decision. Go ahead.
So if we, in our requirements document, when we're writing it, when we're talking about a new user registration, is that something that goes under use cases or under functional requirements?
It's both use case and functional requirement. Yes.
Okay.
Use case is representing functional requirement.
Oh, okay.
Exactly.
Do we have to draw in our requirements documents, or can we just use written description?
You can use written description. However, it's always helpful to have a high-level drawing first, so we can see on higher level. That's why figure is important in any articles. People don't have to look at all the text. They can just look at the figure and just be able to get a high-level idea. It's not required, right? But it's going to be very helpful to have a use case diagram. So what we are looking for is a high-level diagram listing of basically articulate who the user is and what user is demanding in terms of functionality from the system. Okay? Then we want you to provide detail on each use case. And all this chapter is about what is the level of detail needed here. Okay? Just remember the key thing in terms of requirement is that you are looking at the system from outside in. But you're not really in the system. Once you cross over to analysis, basically quote-unquote analysis, that will be high-level design, you are getting into the system. You are jumping into the system. That's the figure I showed you before. If you jump into the client code, you are actually jumping into middle or low-level design. If you jump into code, basically you are implementing. So you are going deep and deep and deep And hopefully you can also come back to assemble the whole thing together as the system, right? When I launch the app, your app, on the phones, for example, do I know you have Solr? I don't have to. Actually, many people don't. I mean, I think most of users don't even know you have Solr. They think everything is in the thing. Indeed. Which is not true, right? So this thing basically is an interface. I mean, so every app you have now pretty much is an interface, just like our client software. That's it. Go ahead.
So for the use case, if we're from the outside sort of looking in as a user, we're going to want to examine sort of these different paths that the user could potentially go down from
Yeah.
a high level. So
Yeah.
go into user reg, and perhaps their username is already taken, or the password isn't long enough.
That's a good question. I see what you're going. In that case, it's still the use case, the new user registration. However, we'll talk about this later. These things called scenarios. Basically, scenario are concrete paths. As you imagine, this user is new and the username is still available. Great. You can give the username to the user, or the username already taken. So these are called scenarios in terms of a use case. So your job is actually balance between use case and the scenario. Scenario are all the possibility, but you are actually using use case to group them into major functionality groups. Go ahead.
So basically, the use case of a user sending and receiving messages could be still separated into two use cases of user sends and receives messages from one person versus broadcasting. Like those are two use cases?
Those
or
are
is
two
it
use
just-
cases. You can, these are two use cases.
Okay.
I mean, can you make it a single use case? Yes. However, eventually, in terms of implementation, you still need to separate them into separate things. That's give you, basically, once you've done this before, you will say next time, say, I know that's going to be better treated as two use cases. That's a good question. So here, you can see that why this is still human intensive, not totally procedural, right? If it can be decided like, okay, exactly, this is the process you run through, then we have a high chance to automate that. However, this is really granularity of your use case. How many scenarios should group into one use case? That's actually based on your experience, right? Your knowledge, how you structure the code, and how those things. That's why design is still human intensive. Okay, coding actually is getting less human intensive because you have a lot of code automatically generated, but design is still very much human intensive. That actually is what you guys got paid for. Actually, you guys not totally get paid for writing code. Yes, the code, right? People will say that, but actually writing code is actually a small portion of your activity. A major portion of your activity is actually figuring out what to write, right? Then spend time to write it down and debug. All right? So see where we are going? Requirement, basically, we are, say, this is our system. That system is called chat app, okay? Then we are basically post it on it and say, oh, it need a new user registration, need a user login, need to send a message to everybody, send a message to a particular group, send a message to a single person if you want to make a different use case, right? Basically, what we are saying is we are posted 1, 2, 3, 4, 5, and we put it up there and say that's our possibility of this user will be using our app. That's your requirement stage. Make sense? Your requirement stage basically identify what is your system. In our case, straightforward, chat app. Who are the users? User who want to talk. You can just represent as a user. Chat user. Then, what are the functionalities? What are the functionalities? New user reg, login, send a message to everybody, send a message to one single person or multiple person, that can be one single use case, retrieve old chat. All right? That's basically is what we observe from outside the app. When you go to your WhatsApp, what are the functionalities? Certainly, when you log in, if you already log in once, you don't have to log in again, right? That's convenient, but that's not our requirement. That's just optimization. That's called, that page already gone. Make your app user friendly. We're talking about basic functionality. We're not talking about improvements and optimization, because that's can go on forever, right? Just think about, how many people are just refining that WhatsApp, right? Make it a little bit better, little bit better, little bit better, right? That's later on, but for us, basic thing. During my time as an undergraduate student, programming this would take me a lot of time. We don't have Java, and we don't have this kind of library infrastructure. We basically have to work with C programs to over really Linux and Linux sockets. Okay, that will be an undergraduate honors project, and now it's become a CS300 class project. Okay, indeed, this would have been undergraduate honors project. You spend like half a year working on this, not even getting close to the functionality we will be able to accomplish. Okay? The scale of programming we're able to do today is much bigger than 20, 25 years ago. Because we are building layer of infrastructure. That's why the Instagram and WhatsApp and all these teams, when they got bought out, they only have like 80 engineers. They're serving like millions and millions of people. 80 engineers. Instagram, when